All right, let's continue. Can you read the problem?
A man normally takes 5 hours to travel at a certain speed from a city A to city B. One day, he increased his speed by 4 kilometers per hour and finds that the journey from A to B takes half and less than the normal time. Find the normal speed.
All right, what did you understand? Did you understand the problem? Okay, now, just the first time read quickly. Now you don't have to understand everything. So now we have to read it again. Now sentence by sentence. Read the first sentence, try to understand. After you understand the first sentence, then we'll read the second one. Okay? All right, a man, right, normally takes 5 hours to travel at a certain speed. Now immediately you should be able to think of this thing. A certain speed. Do we know the speed? We don't know. Let's say that thing is X, kilometers per hour. Because the speed unit is kilometers per hour, right? It is the speed, rate from city A to city B. So immediately we should draw, let's say from here, that is our city A, and that is city B, right? So here the speed is from A to B, moving, right? His speed is X kilometers per hour. And it takes 5 hours to travel. So time is given. What is time? It is 5 hours, right? If he travels at this speed, it takes 5 hours from city A to city B. Okay, that is what's given here. Continue. Read the next second sentence.
One day, he increased his speed by 4 kilometers per hour and
Stop.
finds that...
Stop. Now let's say he increases his speed by 4 kilometers per hour. That is the first situation here, right? The second one is, let me just write it down here. So now we are talking about the second situation. The second situation is saying that one day he increases his speed by 4 kilometers per hour. So what was his speed? His speed was X kilometers per hour, right? So if he increases his speed by 4, what will be his new speed here now? X plus 4, right? Kilometers per hour. That is his normal speed. One day, maybe he was getting late for his work, so he increased his speed by 4. So it is X. Now his new speed is X plus 4 kilometers per hour. And continue.
He finds that the journey from A to B takes half an hour less than the normal time.
Very good. Now before, how long did it take when he travels at X kilometers per hour? It takes 5 hours, right? But now in this case, if he increases his speed, now he can reach his destination earlier. By how much? It says half an hour. So now time is 5 minus 1/2 hours, right? Okay. So now let's write it. That's all. Find his normal speed. What is normal speed? It is X. So that means that we need to find this X. Okay. So from here, let me just write the distance formula here. For the first one, time is 5, speed is X, so that is 5X. For the second situation, right, distance does not change. We are talking about the same distance. Here, time is, what is 5 minus half?
4.5.
9/2, right? 4.5. That is 9/2 times, and how about his speed here? It is X plus 4, right? So now we have two equations here. How do we solve them? I don't need D. The left-hand sides are equal. So that means that also the right-hand sides must be equal. So we got this equation then. 5X is equal to 9/2 times X plus 4. Right? So that's equal to 5X. Just we need to solve this equation. Or let me just do like this. Multiply both sides by 2. So here we have 2 times 5X. Here we have 2 times 9/2 X plus 4. So here we have 2 times 5. It is 10X. 2 cancel out each other. 9 times x, 9x, and 9 times 4 plus 36. Take this to the left hand side. 10x minus 9x. On the right hand side, we have 36. 10x minus 9x, what is it?
X.
What actually we are asked to find here is normal speed. Normal speed is x. So we got x here. Okay, that is our answer. So his normal speed is 36 kilometers per hour. That means that usually when he was going to his work, he travels at this speed, 36 kilometers per hour. Okay? Okay, Shahina, can you read and first understand and try to solve this? I will give you 3 minutes, okay? You can take a piece of paper, read the problem. If you are ready, I'm going to start the time. You have 3 minutes to understand and solve the problem. Ready? Okay, 3 minutes. Start. Shahina, where are you?
Sorry, the computer connection was bad.
3 minutes. Did you get it or still working?
I'm still working on it. I think I have the idea. It's just that I'm not.
Very good. Now tell me your idea. Again, similar question, right? It says,
Yeah.
the sum of the age of Fatima and Ahmad is 38. Okay, we are talking about now, right? Let me just write here Fatima's age and Ahmad's age. Okay, so let's say Fatima's age is N. Then what is Ahmad's age?
N.
No.
Wait.
If the sum of their age is 38, if one of their, actually the Fatima's age is N, what must be that Ahmad's age?
38 minus N.
Very good. That is a big step. Because if you actually cannot write this, we cannot solve this problem. That's the most important step. All right, that's the first step. It says now, right? The present time. Continue. It says that 7 years ago. So that is 7 years ago, right? Now the question for you, Shahina. 7 years ago, what was Fatima's age if she is now N years old?
N minus 7.
N minus 7. How about Ahmad's age?
38 minus N minus 7.
Minus 7. Very good. Now it says 7 year, actually it must be 7 years ago. 7 years ago, Fatima was 3 times as old as Ahmad. That means that this N minus 7, right? That Fatima was 3 times as old as Ahmad. That is our equation. Now we know how to solve this. That's the first step. We actually use the information to model this, and after that we form our equation. Now we have to solve it. So here we have N minus 7. Before we remove the brackets, we have to simplify. 38 minus 7 is 31, and minus N here, right? So now we can remove the brackets, and 3 times 31.
Oh, 331. 93.
Minus 3 times N, 3N, right? Take this negative 3N to the left. So here we have N. Because it is minus, here it becomes plus 3N. Here we have 93. Take negative 7 to the right-hand side, plus 7. So N plus 3N, that is 4N. 93 plus 7, that is 100. So what is N? It is multiplied here, 100 over 4, which is equal to?
20, no.
25.
Yeah, 25.
Good. So it says find their ages. Now I should write here, dot, dot, dot. Fatima's age, now she is 25 years old. And how about Ahmed?
38 minus 25. 13.
13 years old. Okay?
How to do it?
That is the answer.
I see.
Good. All right. Read the problem.
Arya has enough money to buy 24 apples. If the price of each apple is reduced by 5 cents, he will be able to buy an extra apple with the same sum of money. Find the original cost of each apple.
All right. So Arya has enough money. How much money does she have? We don't know, right? And let's say she has P dollars, okay? And it says that to buy 24 apples. All right. Now, do we know the price of one apple? We don't know. Here it says that find the original cost of each apple. Let's say original cost of each apple is, let's say it is X dollars. Right. Now I can write, Arya has P dollars, right? And for P dollars, how many apples can she buy? 24. And what is the unit price of apple? It is X dollars, right? So we need to pay this much then. Because I have P dollars I'm going to buy 24 apples. Each apple is X dollars, right? Okay. Now the second question. If the price of each apple is reduced by 5 cents. Okay. So it says that first I need to change, since everything is in dollars, or should we write this in cents? Okay, doesn't matter. Instead of this dollars, Shahina, let's say she has P cents. All right. So here, all right. So she has P cents, and she's going to buy 24 apples. Each one is X cents. Okay, this thing is, let's say one apple costs X cents. All right. So this cents, actually they cancel each other. We don't have to write this. All right. Now that's the first condition here. How about the second condition? It says that if the price of each apple is reduced by 5 cents. Okay. Here we have P cents here, right? And now the price of each apple is reduced by 5 cents. Now here it was X cents, but now it is X minus 5 cents, right? Reduced by 5 cents. We'll be able to buy an extra 6 apples. But now, how many she could buy? Here, 24. But now, because price is cheaper, she could buy 6 more, right? Because for the same amount of money, for example, if you have $10, okay? If the first part is, let's say one apple costs $2. How many can you buy? 5, right? And how about one apple costs 2.5? How many can you buy? It is 4. And how about one apple costs $1? You can buy 10, right? It's similar to this. Here, X cents, but now to some reason, actually the price was reduced by 5 cents. If it is cheaper, you're going to spend the same amount of money, but now we can buy more, right? So this left-hand sides are equal. Now again, we are going to form equation. As you notice here, all the problems, once we form the equation, the solution method is the same. So here we have 24x. It is on the left-hand side. Cent cancel each other. 24 plus 6, it is 30 times, here we have x minus 5. So now just we need to solve this problem. Here we have 24x, remove the brackets, 30x minus 30 times 5, 150, right? Mm-hmm. So now take this 30 to the left-hand side, 24x minus 30x equals, what is left here?
Negative 6x.
What? No, on the right. If I take it to the left, what is what?
150.
Negative 150, right? So 24x minus 30x, negative 6x equals negative 150. So from here, what is x? X equals negative 150 over negative 6. And which is equal to negative, that is positive. So that's equal to 25. So what is the original cost of each apple? That is 25 cents. Okay? All right, Shahina, can you read the problem?
Yeah. A tank can be fully filled with water using a pipe that fills 20 liters in a minute. A bigger pipe that can fill 25 liters in a minute will take 1 minute less to fill the same tank. How many minutes does a smaller pipe take to fill the tank?
What do you think? Can you solve this problem?
I think so. I'm not sure, but...
Okay, let's do it together, Shahina. But after we do this here, you need to try it yourself, okay? Without looking at the solution. Let's see, you can solve this, because these kind of problems we are going to see again and again in a more different way, okay? All right. A tank can be fully filled with water using a pipe that fills 20 liters in a minute. Okay, that means that here we have a kind of tank, right? And we are going to fill this with water. That's our tank. Okay. All right. So now here, actually, we open a pipe, some kind of pipe here. All right. And we are going to fill with water, right, inside. And it says that this pipe, actual rate, it is 20 liters per minute, right? It says a tank can be fully filled with water using a pipe, some kind of pipe here, that fills 20 liters in a minute. That means that every minute, the water coming out from this pipe is 20 liters, okay? All right, a bigger pipe that can fill 25 liters in a minute. So here we have, let's say, pipe 1, and we have another pipe here. Let me just use another different color here. We have another bigger pipe here. That is bigger one. All right. So this bigger pipe, it says here, what is it? 25 liters in a minute. So the rate of this pipe is, it is 25 liters per minute. Okay. 1 minute. All right. A bigger pipe that can fill 25 liters in a minute will take 1 minute less to fill the same tank. Okay, how many minutes does the smaller pipe take to fill the tank? How many minutes does the smaller pipe take to fill the tank? What does it mean? Shahina, here we have two options here, right? Either I can use the smaller pipe to fill this tank with water, or I can use the bigger pipe to fill this tank with the water. Okay. Now, Shahina, here, do we know the volume of this container?
No.
We don't know. Okay, let's say the volume of this container is V. Okay, it's very similar to distance time formula. All right. So now, assume that the first case, we open only the small pipe. Okay. Now, what is the rate of the small pipe? It is 20 liters per minute, right? So if I just open the small pipe, how long does it take to fill this tank?
1 minute.
We don't know. How do you know that?
Oh, yeah.
Because I don't know this volume. I know the rate, but I don't know how long does it take. So assume that if I just open the small pipe, it takes 10 minutes. Okay. So the rate is 20 liters per minute, 20. And every minute, 20 liters of water is coming out from this pipe. And it takes 10 minutes to fill this tank. That means that if I just open this tap from here, after 10 minutes, this will be full. That means that the amount of water is equal to V. The second situation, the second condition here, now a bigger pipe, right? So again, we are also, in the second case, we are not using this small pipe. Now I want to fill this tank with water using this big pipe, right? And in the question, it says that it is 25 liters in a minute. Excuse me. So here it is like speed and time, speed and time. So here it says 25 liters every minute. It will take 1 minute less to fill the same tank. Now with smaller pipe, it takes 10 minutes, right? 10 minutes. How about this bigger pipe? How long does it take? T minus 1, right? It's like speed and time. If you travel at higher, slower, for example, at slower speed, it takes more time. If you travel at higher speed, it takes less time, right? So that means that it's bigger pipe, so it takes less time. By how much? It says by 1 minute. Okay, now how many minutes? As you see here, again, here we got very similar question. Left-hand sides are equal, right? So that means that also the right-hand sides must be equal to each other. So now we are going to form our equation. Then this 20t must be equal to 20 t minus 1. Sorry, it's 25 here, right? Because 20t equals 25 times t minus 1 because the left-hand sides are equal. So now we need to solve this equation. If you solve this, 20t is equal to 25t minus 25. Take this to the left-hand side. 20t minus 25t equals negative 25. 20 minus 25, that is minus 5t. That's equal to minus 25. And what is t? Negative 25 is divided by negative 5, which is equal to 5. And what is it? That is how many minutes? That is t we are looking for. Does the smaller pipe take to fill the tank? This is a smaller pipe. It takes t minutes, right? That is the answer. It takes 5 minutes for the smaller pipe to fill the tank. Okay?
Okay. So then it takes 4 minutes. Okay. Let's see.
Now, if I close the solution, can you solve it?
Let me see.
Maybe you should read the problem once again, okay? If you understand the problem, Shahina, the solution is easy. First, read the problem, as I told you earlier, okay? You really want to know you understood or not. Read the problem, close your eyes. Can you visualize what's going on here? Now, when you close your eyes, so in front of our eyes, we have a big tank, and we have two different pipes. One is smaller, another one is big one, right? And we just open the first tap, it takes 10 minutes. If you open this bigger one, it takes again t minus 1 minutes, right? And the rate of the first pipe is given, the rate of the second pipe is given. I mean, there are things. Maybe, I mean, as we go further, we solve more and more problems, you will be able to do this. But now you have the practice, okay? Read the problem, close your eyes. What did you understand? Can you explain that thing to yourself? Okay, now I'm talking about two pipes, about a tank, and blah, 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 right? Okay, if you can say this to yourself, that means you got some idea. Open your eyes, read it again. Now write it down, what you understood. Okay? All right. Okay. Read it.
Mary is twice as old as John and half as old as Bob. In 22 years' time, Bob will be twice as old as John. How old is Mary?
All right, Shahina, now I'll show you another method here. Actually, this is called, we call this in math, what is it? Age problem. Okay, in math, we call this age problem. So solving an age problem, one of the best technique is using tabulation. That means that draw a table and write your data in the table. So about how many people we are talking about? We are talking about Mary, right? And John and Bob. So I'm going to make this kind of table. And also we are talking about two different times, right? That is now, because that is means we are talking present time. And 22 years time, we are talking about future, right? So now I will make this table. Here we have 3 people now and 22 years later, right? Okay, that is the first thing. All right, the first guy and the second guy. Okay, and now and the future. Now or present and the future. All right, now we are going to write here. We are talking about Mary here. Let's say Mary. And John, here we have John. And Bob, here we have Bob. Okay, now let's read this. Mary is twice as old as John. Do we know John's age?
No.
No. Let's say John's age is N. Now what is Mary's age?
N times 2.
2. That is Mary's age is now 2n. Okay, and Mary is twice as old as John, and half as old as Bob.
Oh.
Now tell me, if Mary's age is half as old as Bob, what is Bob's age?
M times 2.
2n times 2. So that is 4n, right? Because half of 4n is 2n. Okay. Okay, got it here?
Yeah, I got it.
Now in 22 years time, that means after 22 years, Mary will be 2n plus 22. How about John? He will be n plus 22. How about Bob? He will be 4n plus 22. First, we need to write it down here. Then we'll write our equation. In 22 years time, Bob will be, okay, Bob, where is Bob? Here, right? That is 4n plus 22. That is Bob's age. Will be twice as old as John. What is John? Here. That means it is equals twice as old as John. That is John's age, right? How old is Mary? So we need to find 2n, Mary's age here. So if we solve this equation for n plus 22 equals 2 times n. 2n plus 2 times 22, 44. Now we have 4n, take to the left-hand side, minus 2n equals, here we have 44. Take 22 to the right-hand side, minus 22. 4n minus 2n?
2n.
2n equals 44 minus 22?
22.
It is 22. Now n is equal to 22 over 2, which is equal to?
11.
11. Okay.
Oh, so
now we need to answer the question. How old is Mary now?
She is 22 years old.
Because we need to find 2n. That is 22 years old.
Oh, so Bob is 44. Okay.
Mary is. Okay?
Okay.
Good. The last problem, okay, and we'll finish our class. Read it.
Alice and Belinda start off simultaneously.
Simultaneously. What does simultaneously mean? At the same time, right?
Oh, yeah. Alice and Belinda start off simultaneously from 2 towns to meet one another. If Alice travels 2 kilometers per hour faster than Belinda, they will meet in 3 hours. If Belinda travels 1 kilometer per hour slower and Alice's speed is 2/3 of her previous speed, they would meet in 4 hours. How far apart are they?
Oh, again.
Oh, 2 towns. How far apart are the 2 towns?
It's quite, I think, one of the challenging problem in this chapter, Shahina, okay? But actually the idea is simple. So now we had just read it. We have to read one more time, a bit slower now. Okay, and at the same time, you try to write it down here, what is given here. Alice and Belinda start off simultaneously from 2 towns to meet one another. That means that here, that is town A, right? And here we have town B. So these 2 girls, they are going to meet to each other, right? They start traveling at the same time. Okay, all right. So now, the second part. Now that's what is it about, the first sentence. If Alice travels 2 kilometers faster than Belinda, okay? And do we know Belinda's speed? Let me just write down. Do we know Belinda's speed? We don't know. So let's say Belinda's speed is X kilometers per hour. Now it says that if Alice travels 2 kilometers faster than Belinda, then Alice's speed must be x plus 2 kilometers per hour, right? They would meet in 3 hours. So in this case, so here t is equal to 3 hours. That is the first condition, right? The second one, if you actually I can just write here, what is the distance between these two towns? We don't know. Let's say it is d kilometers. So here that d is equal to this actually 3 times x plus 2 plus 3 times x, right? Because after t hours, this girl travels maybe this much, and this girl travels maybe this much, and they meet each other here. Okay, now the second part. If Belinda travels 1 kilometer per hour slower and, okay, 1 kilometer per hour slower, and Alice's speed is 2/3 of her previous speed. Okay, now we are going to write here. If Belinda travels 1 kilometer per hour slower, what is Belinda's speed here? It is x, right? Now, if you're saying that if he travels 1 kilometer slower, now it is x minus 1. And Alice's speed is 2/3 of her previous speed. What is her previous speed? X plus 2. So that is 2/3 of her previous speed. That is x plus 2. Okay. They would meet in 4 hours. At the time here, t equals 4. Then this distance that equals, what is it? 2 over 3 x plus 2 times, that is speed, time is 4 hours, plus the second one is 4 times x minus 1. Okay, because here, maybe again, actually they are moving towards each other from town A to town B. Actually, she's walking towards each other, right? After 4 hours, they meet each other somewhere here, meeting point. So these two things, again, dd, same. Right-hand side, they must be the same to each other. So now we have this equation, 3x plus 2 plus 3x is equal to, here, multiply this 4 by 2. It is 8 over 3 x plus 2 plus 4x minus 1. That is our equation. Okay, Shahina. So you have to solve this equation, finish it, this problem, all right? And once again, read this. Shahina, that much is enough. You keep practicing solving problems. Try to finish chapter 1 as soon as possible, okay? If you have any question from chapter 1 or chapter 2, on next time we will meet on Friday. We can discuss and solve them together, okay? If you have no question, we will finish this review questions and start new chapter, okay? All right, bye-bye. See you on Friday, okay?
See you.